Wasn't there problems online?
Maybe. Or no, they're already up from the past.
Oh, okay.
Yeah, they're up there. But let's see if we can get through them all right now, too. But yeah, they're up from past semesters. You guys know what I mean, right? You're going to YouTube, just search through. Because this summer, I taught this summer. They're up there. Okay, first one, Brenda here. Brenda. Oh, I never give you. All right, so let's crank through. So roll a regular 600 die twice. So I haven't shown this like at all. So let me show you. If you roll a dice twice, let me just make a separate chart for that. Here, and you want to put this on your 3x5 card. I'm just going to make a big array here. This is the roll a die twice chart. Because what can happen when you roll a die twice? Well, let's lay out the various possibilities in kind of an organized fashion here. Okay, I made a 6x6 array. That's just 6 by 6. 6 across, 6 down. And you can get a 1 and then a 1, or a 1 and then a 2, or a 1 and then a 3, or a 1 and a 4, a 1 and a 5, a 1 and a 6, a 1 and, or not 1 and a 7. What am I doing? And, or a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a... You make sense on what I'm doing there? When you roll 2 dice, the first die could be a 1 and the second die is 6. Or the first die could be a 2 and the second die is 6. And on you go, right? I'm just going to list out all the different things that can happen here. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. It's getting kind of scribbly. My 5s always look bad. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. All right. So I'm going to put that on another page if I can do that. Good. All right. It's a little funny. Okay. So there we go. So there's 6 different things, 36 actually altogether, right? 6 by 6 array, 36 different boxes. Those are all the different things that can happen when you roll 2 dice. So anytime they ask you a question about rolling 2 dice, they say, what's the chance of this or the chance of that? Use this array. Be good to put it right on your 3x5 card. And we'll start using it. You ready? Let's go back to the question now. If you roll 2 dice, what's the probability that at least one of the rolls will land even? At least one of the rolls will land even. At least one of the rolls even. So let's write that down. At least one roll even. Now what does even mean? 2, 4, or 6. So we're saying, hey, we really want to get a 2, a 4, or a 6 on at least one of the 2 dice. Both is okay, but just one would be good as well. That's what they're asking, right? They're saying among all 36 things that can happen, how many of them have like a 2, a 4, or a 6 on one or both dice? That's what at least one means, one or more, right? So let's just circle them. Let's just count them. Here we go. 1, 2. That has an even number on one of the dice. 1, 4, 1, 6. Those all have at least one of the 2 dice coming up even, right? And this whole entire column, because they all start with 2. So at least one of the numbers is even. Keep going. And then the 3, 2, the 3, 4, the 3, 6, those have at least one of the 2 numbers being even. Is this making sense what I'm doing? Is this good? Johnny, you good with this?
Yeah.
Making sense?
Yeah.
All right. Trying to read y'all faces. I can't tell exactly. Good? And then, okay, how about the next column? What about the 4s? How many of them have a number that's even? Well, the whole column, because they all start with a 4. Right? Because at least one even means it could be one or both. Okay, next one is 2, 5, 5, 2, 5, 4, 5, 6, and then the 6s is the whole column. So out of all, so the probability, remember how probability always works? It's always over the total, huh? It's always the number of whatevers over the total. So the total here is 36. When you roll 2 dice, there's 36 different things that can happen, right? We can tell from that chart. And how many of them have a number being even? Well, there's 3 in this one, 6 here. Let's add these up. 3, 6, 3, 6. That's really 9, 9, 9, 27, 36. Yeah, and then reduce that. You're right on. Reduce, divide by 9, divide by 9. 3/4. The probability, if you roll 2 dice, you're going to get one of the 2 numbers being even, is 3/4. There it is. So if you're playing a game, Monopoly, whatever, some kind of dice, you roll the 2 dice, you're thinking, I really just need one of these dice to come up even, I win this game, with chance of 3/4. Isn't that good?
Wait, how did you get the 3 plus 6 plus 3 plus 6?
There were 3 circled results in this column, all 6 in this column, 3 in this column, all 6. Just counting the different ones that had one of the numbers being even. All is well. There's number 1. So 3/4, 8. Question 2. If we roll a regular 6-sided die twice, same thing. Doesn't matter. 2 dice, 1 die twice, whatever, same thing. Probability that both rolls land with same parity. That's a weird word. Both even or both odd. Okay, so both even, both. Let's go back to the chart. So we're talking about the same thing. In fact, maybe I'll just go to this chart here. I know that looks kind of weird. I just copied my copy, so hopefully that'll work. All right, here we go. Both even or both odd. So now we're doing question number 2. So let me write that. Question number 2. You want both even or both odd. So you say, hey, how many have both even, both odd? Well, here's both odd. You know, odd is 1, or even's 2, 4, 6. Odd's 1, 3, 5, right? So both odd, both odd, both odd. Okay, good so far. Both even, both even, both even. Both odd, both odd, both odd, both even, both even, both even, both odd, both odd, both odd, both even, both even, both even. Sounds like some kind of not very exciting song. All right, so there's 3 results here, 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 all the way. It's 18 out of 36. Divide top and bottom by 18, actually, or just comes out 1/2. Half the time, you'll get both dice even or both dice odd. Is what that means. Half the time you won't. Half the dice will be 1 even, 1 odd. Making sense? Oh, good. Okay, if I keep moving? All right. Okay, that's number 2. So half, D. Let's keep going. We got to go on. Okay, so number 3. Oh, whoops. What am I doing? I'm getting confused. Come on. There. Okay, so number 3. Fair coin is tossed twice. So remember what you do the coin. So that is heads, tail for the first flip, and then heads or tail for the second flip, and then the 4 results are head, 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 tail, tail, head, tail, tail. 4 results. So when you flip a coin twice, there's actually 4 different things right here that can happen. You can get both head first then tail first then head, or both tails. You don't really, if you want to skip the branching, you can skip it. All that really matters in the end is the results. If the branching helps you, great. But it's not required. All we need is those results, those 4 different results. Now, what's their question? What's the probability? I can't read it. What does it say? Come up that both tosses are heads. What's probably both tosses are heads?
1 out of 4.
Yep, here it is right here. It's this out of 4. 1 out of 4. There. Good? On that. Keep rolling. Keep moving. So here we go again. We're doing I'm just going to write the results. Head, 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 tail, tail, head, tail, tail. That's all we care about. Okay, fair coin twice. At least 1 head. So it's going to be out of 4, because the total always goes in the bottom for probability, huh? So at least 1 head. So out of those 4 different possible results, how many have at least 1 head?
2 plus.
This, and that, huh? 3/4. Make sense? Those all have at least one head, don't they? The only one that doesn't is both tails. So the probability is actually 3/4. Answer A. All right. Number 5. Fair coin is tossed 3 times. Okay, now I'm going to show the branching again. That might help you. You don't have to. If you can just jump right to the results, that's fine. So it's a little bigger deal here. Head, tail for the first flip. And then head, tail for the second flip. And then from there, head, tail. I'm going to run out of room. Head, tail for the third flip. So now I won't ask you more than 3 flips, I promise. This is as big as it'll get. So here's 3 coin flips. So in the end, what are the different possible results? Heads, tail. Heads, tail. So you understand how I'm getting those? I'm just following the yellow brick road, the branching through the tree. Like I just went heads, tail, head to get there. And then head, tail to get here. See how I'm just following the branching? Am I making sense? You just start here on the left, you just follow the road. Head. Head, tail. Right? Are we good with that? I'm just following it on out. So tail, head. Tail, head, tail. Tail, head, tail. There we go. There it is. 8 possible results when you flip a coin 3 times. It doubles, doesn't it? Have you noticed it doubles? There were four results for 2 flips, 1 more flip, now there's 8 results. If you flipped it a 4th time, there'd be 16. It just gets bigger and bigger. All right, so anyway, what's their actual question now? Find the probability of tossing 3 heads. Okay, so it's going to be something over 8. The total always goes in the bottom. 3 heads. There it is. 1 out of 8. Boom. Done. We good? 1 out of 8's probabilities?
Heads 3 times?
Right. Yeah. Probability of tossing 3 heads. So that's 1 out of 8 different things that can happen. Now, what if they said, what's the probability that you get at least 2 heads? At least 2. Well, then I would have circled all the ones that have 2 or more. So this one. And that one, there'd be 4 out of 8, actually. Anyway, whatever they ask, you just make that the top, right? We good? I move on? Questions? So definitely have on your 3x5 card. I would just put the map of the 3 flips, the 2 flips, and then the 6x6 dice array. Have those just already made on your 3x5 card. That way you won't have to mess around making them during the test. That'd be easier for you. Okay. On we go. Okay, and I'm going to put the dice chart here. Boom. Okay. So question number 6. What is the probability of rolling a total of 7? Total of 7. So if you're playing a game, you're rolling 2 dice, and you really want the total of 7. You want the dice add up to be 7, like a 4 and a 3, or a 5 and a 2, or a 6 and a 1, right? So that the 2 dice add up to be 7. Is that making sense? Like that'd be like Monopoly, right? That's what you do in Monopoly. You roll. If you're playing Monopoly, and your friend's about to roll, and you count, and he's like 7 spaces from the boardwalk you own, and you're thinking, I hope he rolls a 7, right? And you roll. What's the chance he's going to roll a total of 7? How do you find the probabilities of the various totals of 2 dice? Well, you use that dice chart again. There it is. That's anytime they give you 2 dice question, we'll use that same chart. You have that in your 3x5 card. Now let's look at that thing for a second, and you tell me how many of the boxes are numbers that add up to be 7. Can you circle them, or can you see them? Let's circle. Here's one right here, huh? 6 and 1 adds up to be 7. 5 and 2 adds up to be 7. 4 and 3, 3 and 4, 2 and 5, 1 and 6. All those make a sum of 7, a total on the 2 dice of 7, don't they? So, what's the probability of getting, probability of that your sum or your total is going to be 7? What is it? The bottom is 36, right? The bottom is always the total. There's 36 total things that can happen when you roll 2 dice, when you're playing Monopoly or playing craps at the casino. 30, that's 2 dice game. So roll 2 dice, 36 different things happen. How many of them have a sum of 7? Did you count them? 1, 2, 3, 4, 5, 6 different boxes out of the 36 boxes. So reduce that fraction like we always do. Divide top and bottom by 6, 1/6. The probability of rolling a total of 7 is 1/6. Is that good? Look, you could do that? Just go on back. 1/6, there it is. What's the next question? What is the probability of rolling a total that is neither 7 nor 11? Now, 7 and 11, if you play craps, that's, I forget it. 7 and 11 is something good. So what's the chance that you'll not get 7 and not get 11? Well, we've already got the boxes that make sum of 7. Where are the boxes? Can you look up there for a minute? Where are the boxes? How many boxes make a total of 11? Let me give you just a second. See if you can find that. Do you see them? Where are the ones that total 11? 6 and 5, and notice they're in a diagonal again. See what I mean? Sum of 11. So, how many total boxes? Let me get rid of the last problem here. How many total boxes? Now this is, sum of 7, that's 6 boxes. Sum of 11, that's 2 boxes. So add that up, that's 8. 8 boxes are either a sum of 7 or 11. So how many boxes are not? Not would be 36 total minus 8. Was that 28? 28 boxes are not. 28 boxes are not 7 or 11. You with me? I just subtracted from 36. So, what's the probability? The bottom is always the total. 36 boxes total. How many are not 7 or 11? 28, huh? Good? Then reduce that like we always do. Divide by 4. What's that going to be? 7/9. So there we go. If you're rolling 2 dice and you want to not get a total of 7 or 11, the probability is 7/9. By the way, what's the probability that you will get 7 or 11? 2 out of 9. Right. Right? If the chance that it's going to rain tomorrow is 7/9, what's the chance it won't rain? 2/9. Right? The opposite. Always has to make 1 altogether. Yeah, so if the chance of not getting 7 or 11 is 7/9, then the chance of getting 7 or 11 is 2/9, isn't it? They didn't ask me that, but anyway, 7/9. So 7/9. It's always A. Is it me or has it always been A for a while here? So there we go. 7/9. All right, let's go back to that die. I think that's all the dice question they're going to ask you. Let me go back just for a second. Notice if you need to do anything with this chart, the sums are always down a diagonal. Do you know what I mean? Let me give a fresh chart here, and just make a couple points, and we'll move on. So, like I said, this diagonal, the main diagonal, the sum of everything on that diagonal is 7. Right? They all add up to be 7. We already did that. Okay. Go down another diagonal, like let me say, let's do the next diagonal right here. What's the sum of the numbers on that diagonal? 8. They ought to be 8. Try the next diagonal. What's the sum of the numbers down this diagonal? The sum is 9. And then do the next diagonal. The sum is 10. The sum is 11. And here's the last one. Sum is 12. And then if you go the other way, like this diagonal, it goes down. The sum is 6. The sum is 5. And I'm running out of colors. And the sum is 4. Sum is 3. And the lowest, snake eyes they call it, sum is 2. Do you see how the sums go down the diagonals? I don't know if you ever noticed that about dice chart. So if you're playing a game, let me ask you this. So the biggest diagonal up there, the biggest diagonal is the sum of 7, isn't it? Because that has 6 boxes. And then as you get off of that, either down by 1, sum of 6, or up by 1, sum of 8, you have 1 less box. Now you have 5 boxes. 5 boxes here, 5 boxes there. So there's only 5 out of 36 chance of getting a sum that's 6 or getting a sum that's 8. Then you go another one off. Now there's only 4 boxes for sum of 5 or 9. Go to 10 and 4. There's only 3 boxes. 11 and 3. There's only 2 boxes. And the highest and lowest, 12 and 2. Very rare. Only 1 out of 36 chance you're going to get that. You ever notice that? So the most likely sum, if you roll 2 dice, is? What's the most likely total? 7. That's right. It occupies the main diagonal. It's the most likely. It's 1 out of 6. The second most likely total is tied by 8 and 6. They both have 5 out of 36 chance of happening, don't they? See how that works? So 7 is the main expected probability, and as you get away from 7, the further you are above or below, away from 7, the less likely that sum is. Anybody ever play Settlers of Catan? That little family board game? Played that? Yeah, that plays on these dice probabilities. That has the best properties. I don't know if you ever noticed, the best properties have sums that are 8 and 6, and you wonder, why are those more likely? Well, because you see why now. Those are more likely. When you're rolling the dice throughout the game, you're more likely to land on numbers like that than you are properties that only have sums of 11 and 10 on all that. So, anyway, all those dice games and all the probabilities that go with them all come from this. Whenever we play family games, I think my family gets annoyed with me. I'm always telling them the probabilities of the different things, and I don't know if they always want to hear that. But yeah, so, and like I said before, who knows these probabilities quite well? The casino industry, right? So no, if you're there rolling the dice or pulling the cards, it's not random. They have calculated it all far in advance, and you will lose. It's already guaranteed if you play enough, right? Go be a wise gambler. All right, I've been over that already. You've heard my spiel. So here we go. So number 8, how many different passwords are possible? Okay, this is like the license plate thing, code word kind of thing. So it's decisions, options. Here we go. 5 capital letters. No, that's it. Just a computer password consists of 5 capital letters. All right, here we go. Remember what I suggested to do. I said, just do one. Just do one. I'm going to pick one. Here's my password. It's WAMBX. I picked a password. Remember, I really encouraged you on these random password kind of problems. Just pick one, then think back, say, okay, what did I just do? How many decisions did I make? And how many options did I have for each decision? I just made 5 decisions, didn't I? For my first decision, in which I chose the W, how many options did I have? Well, 26, because remember, there's 26 letters in the alphabet. I could have chosen any of the 26 letters in the alphabet. You want to definitely have that if you're not already familiar. 26 letters in the alphabet. Next decision, 26, 26, 26, etc. Right? Which is 26 to the 5th power. That good?
You would have to specify, right, that you cannot use the same letter more than once.
Yeah, now if they say that, yeah, good point. Good point, Johnny. Sometimes, remember some of the other ones we did, they would say, hey, you can't repeat the letter or whatever. What if they did that? What if they say, you pick a password, but you can't have 2 W's or you can't repeat any letters? Then what would we do? We'd do 26 for the first one, and then what? 25, because you can't choose whatever you chose the first time. And then 24, because you can't choose whatever the 2 you chose the first 2 spots in. It just goes down by 1 every time, right? If they say no repeating, then it always goes down by 1, because you always have 1 less option if you can't repeat that thing you just chose. Right? Okay, good. Everybody good with that? And by the way, sometimes they multiply that out in their calculator. Like, I don't even know what 26 to the 5th is. It's something crazy big. It's 881,000. No. It's gigantic, crazy big. So, well, 1188, 1376. And it's 11,881,000. Sometimes they multiply them out. Sometimes they just leave them this way. You just do whatever they did in the multiple choice. They just left it that way, so I grabbed it. They could go either way, though, on the real test. I don't want you to be surprised. Okay, next question. Get this out of the way. How many different passwords start with Z, end with W? Okay. Let me encourage you to do it. Actually do it. Pick a password that starts with Z, ends with W, do whatever you want in between. And then think back and think, okay, what did I just do? How many decisions did I make? And how many options did I have for each of my decisions? So I'm going to pick one, Z, M, A, B, W. All right, I made 5 decisions when I picked that password. I started with Z, and I end with W like they told me to. 5, think about how many options you have for each of those decisions. So for the first decision, the Z that I chose, how many options did I have there? 1. I only had 1 option. I had to do Z. And that goes for the W at the back also. You had to start with Z. You had to end with W. You only had 1 option in those spots. Okay, when I chose the M, how many options? 26. These are all 26. They didn't say anything about can't repeat. So it's really just 26 to the third, isn't it? Because times 1 doesn't do anything. There it is. Does that make sense? On we go. License plate. Consists of 5 capital letters. Is that it? Wait. The license plate consists of any 5 colors from the ordinary English alphabet, except for O, I, and Q. Okay, so 5 letters. How many license plates start with Z, end with W? All right, do it. Actually do it. Make one up, and then after you're done, think back. Think, okay, how many decisions did I make? How many options for each decision? Multiply those together. Give me just a second. Okay. I'm going to do it. So what do you got? Start with Z? What they said? Yeah, start with Z and with W. So start with Z. I'm going to do the same thing. M, A, B, W. Okay. I made 5 decisions. First decision 1, last decision 1. You had to start with Z and with W. Now, when I chose the M, how many options? Well, not 26 because I couldn't use O, I, and Q. So I had 23 options. Does that make sense? Times 23 times 23. So it's just 23 to the 3rd power. Boom. Good? There were just 3 letters you could not use, they said. So that gave me 23 options for the 3 letters in the middle. 11. How many of the license plates begin with the word math? Now, so as you're not confused, that is my job, to help you not be confused. Don't confuse it with what they said in number 10. It has nothing to do with what they said in number 10. Number 11 is a completely new problem. Now, it has to do with these instructions. See, these instructions are above number 10 and 11, so they apply to both 10 and 11. But nothing from 10 applies to 11. Like nothing about starting with Z and ending with W. That doesn't have anything to do with number 11, right? Everybody see that? Just the overall instructions apply to 11. So, take into account the overall instructions and try number 11. Actually do one. Really, this is a super important time. This question is simple if you actually do one. So actually make a license plate that starts with math.
That starts with what?
Math? Don't you have a license plate that starts with math? Me either. Math? All right. So I'll do one. Math. And then we're supposed to have 5 letters, so how about math W? Or whatever. It didn't have to be W at the back. Yeah, maybe I'll make it. Math A. I'm going to get an A in my math class. Math A, right? All right. So I made a license plate fitting what they said. Starts with math. But it had to have 5 letters. And it could not use O, I, or Q. I could not have done math Q or math I or math O because they said no. That still applies, right? That's instructions above 10 and 11. Those apply to 10 and 11. Okay, so how many
Sorry, never mind, I'll let you explain.
how many decisions did I make there?
23.
I made 5 decisions.
Because the math, you can't change it. Doesn't it have to start with that?
Yeah, we'll get there, but I made 5 decisions, wouldn't you agree? I chose an M, I chose an A, I chose a T, I chose an H, I chose a A. I made 5 decisions. For my first decision in which I chose the letter M, how many options did I have? How many different things could I put there? 1. I had to put M. I had to start with the word math. I had one choice here, one choice here, one choice there. Right? I had to do math. Now, how many for the last spot? 23. Because there's 23 letters left. I can't use the O, I, or Q, or whatever it was. So it's just so 1 times 1 times 1 times 1 times 23 is just 23. There's only 23 license plates that start with the word math, right? It's math A or math B or math C or math D or math E, on through the alphabet. Those are the only ones. There's only going to be 23 of them. That good? Is that doing it thing helping? I think that's what really helped me when I took a whole class on this, is when I would physically do the thing. It would be easier for me to see it. I go, oh yeah, I just made these decisions. All right. All right, number 12. How many different Tasmanian license plates? Well, whatever. 4 capital letters followed by 3 digits. So 4 letters. So I'm gonna do one. WAMB 765. So 4 letters, 3 digits. There doesn't look like there's any restrictions of any kind. So I made all these decisions. What is that? 7 decisions. For my first decision, I had 26 options, 26 options, 26 options, 26 options for each of the letters. When I started putting digits down, how many options did I have? 10, 10, and 10, right? Because there's 0 through 9. That's 1 through 9 is 9, and then the 0 is 10 options, right? For the digits. So just multiply that together, or maybe they have it already. That's 26 to the 4th power times 10 to the 3rd. Right there. It's always A. It's often A. All right, a lot of A's on this practice exam. Stop me if you want to talk about it. I'll keep moving. Number 13, unless you stop me. How many Tasmanian license plates end with 66, like a 66 Mustang or something? They end with 66. What am I going to do? I'm going to do it, right? Let's try that. Actually, write one. Pick a license plate that fits their criterion and ends with 66. And then think back to what you just did, decisions and options. Okay. TVPW866. So I just did one. Okay, I made all these decisions. I had 26 options, 26 options, 26, 26. And then I had 10 options, and then 1 and 1, because I had to do 66 at the end. Right? I had to do 6 and 6. There's only one option for each of those. That make sense? We good on that? That's, what is that, 26 to the 4th? 26 to the 4th times 10. 24 times 10. There we go, B. Oh, it was B this time. Good. Move on. Unless you have questions. All's well. Okay, so start with, so you still have to have, what is it, 4 letters, 3 digits, huh? So like add W 365 or whatever, right? 4 letters. I just picked one. 4 letters, starts with the word add, 3 digits. There's a license plate starting with the word add. So think about decisions and options. They said I had to start with the word add. So that's 1, 1, 1. 26 options, 10, 10, 10. So looks like they, see how the answers have all been multiplied out? So they want me to actually multiply that out. That's going to be 26,000. There it is, D. Is that okay? It's all good? I'll move on. Number 15, French restaurant offers a menu consisting of 5 different appetizers, 3 salads, 2 soups, 7 main courses, 3 desserts, Restaurant offers different combinations of fixed price dinners on different days of the week. Number 15, on Monday through Thursday, the fixed price dinner consists of a choice of appetizer, a soup, a main course, a dessert. Assuming you don't pass on any of these, how many different fixed price dinners are possible on these days? Okay, so we've got to pick an appetizer. Let me just write it out. Appetizer, a soup, a main, and a dessert. Okay, they're skipping the salad, I guess, huh? All right, so if you got to pick, so it's just decisions, options. There's the decisions I need to make. I need to make a decision on my appetizer, make a decision on my soup, main, and dessert, right? Those are my decisions. For each of those decisions, how many options? How many options for appetizer? 5. How many options for soup? 2. How many options for main? 7 main. How many for dessert? 3. Multiply those together, 210. C. Good? 210 options? Let's go on to number 16. Number 16. Friday and Saturday fixed price dinner is appetizer. I'm just going to write down appetizer, soup or salad. Watch out. They're going to try to trick you there. Soup or salad. That's one decision. It's not both. It's not saying soup and salad. You don't pick a soup and pick a salad. You make one decision and it's either soup or salad. Everybody see how that's one decision? Main and dessert. So if you look back up, there's how many? 5 appetizers, 3 salads, 2 soups. So when I pick either a soup or a salad for my second decision, how many options? 5, because there's 3 soups, 3 salads, 2 soups. You can have any of those 5 things, huh? The main is 7 still, and the desserts are 3. 25, whatever that is, I don't know what that is. 525? B. Good. Number 7, 10p3. Use your calculator. Do y'all know how to do that? You can use your calculator, or you can do it by hand. I don't care. It's all good by me. It doesn't matter to me at all. 10p3. You can use I'll show by hand. The by hand way is you start at that number, and the second is the number of numbers. So you start at 10, do 3 numbers. 10 times 9 times 8, 720. B. So start at 10, do 3 numbers. 10, 9, 8. It's always going down by 1. That's that one. Now, number 18. 18 is the C. So again, you start at 8, do 5 numbers. 8, 7, 6, 5, 4. Start at 8, do 5 numbers, right? You start at 8, do 5 numbers, but the C means cut. Stands for combination, and you cut it. You divide it by what? By what? The second number on down to 1. 3, 2, 1. 5, 4, 3, 2, 1 on the bottom. Am I making any sense? So you can just use your calculator if you have the C button. You know how to work it, just hit that. But if you're not, the difference between P and C has the dividing, the cutting. P does not. C has the cutting. So if you do that in your calculator, you're going to get 56, aren't you? B, 56. Is that good? I'll move around rapidly. If you're okay with that, I'm going. Okay. Spinner below, regions, blah, 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 blah. What's our question? What's your chance it's going to land on region 5? So, they're telling me angles. So 1 and 2 are 90, so I'm going to put that in. This is 90. Let me use a different color here. So region 1, this is 90. Region 2, this is 90. Region 3 is 100. This is 100. Region 4 is 60. Okay, they gave me everything but region 5. Can I find region 5? How so? Subtract the total from 360, right? 360 is all the way around a circle, right? So if you add up 60, 100, 90, and 90, what do you got? 24, 340. So 360 minus 340 is 20 left. So that means this must be 20. Region 5 must be a 20-degree angle opening because that makes 360 total, doesn't it? So if you spin that spinner round and round she goes, what's the chance you're going to end up on region number 5? Probability always has total on the bottom. What's the total of the angle? 360, and on the top goes the 20. The probability you're going to land in region 5 is 20 degrees out of 360 degrees. That's the portion angle 5 occupies, right? Reduce that fraction. Divide by 20, top and bottom. Get 1 over 18. 1/18, there it is. 1/18 is the chance you're going to end up on region number 5. Questions on that one? Number 20. 4 drivers, A, B, C, D, enter a race. According to the odds makers, probably that A will win is 0.4. Others have equal. Okay, so in other words, A is 0.4. B, C, and D are all equal. The other 3 drivers all have equal probability. So how do you find them out? Well, the trick on this is, if the chance of rain tomorrow is 20%, what's the chance that it will not rain? 80. You have to add up to 100%, or decimal 1.0, huh? So the various probabilities, if you put everything that can happen, they have to add up to 1. One decimal, 100% of the same thing. You with me? So what that means is, on this problem, see if I got some space here, A plus B plus C plus D must add up to 1.0 decimal, or just 1, which is 100 percentage. Remember, I take 100%, move the decimal back 2 places, becomes 1.0 decimal, right? So what? Okay, well, the A is 0.4. I know A is 0.4. What's B, C, and D? I don't know. Call them all X, because they're all the same. See why I call B, C, and D all X? Because they're the same. I can call them by the same letter. I don't know what they are, but they're all the same. So I have a little equation here. 0.4 plus 3x is 1. See my little equation? I'll bring it up here. 0.4 plus 3x is 1.0. Right? X plus x plus x, 3x. That's a little algebraic equation. Remember your glorious algebraic days when you solved x equations? Maybe they weren't glorious. How do we solve that for x? X is saying, I want to be alone. Get rid of this 0.4, get rid of this 3, so I can be alone. What's the first step? Subtract. Yeah, remember when you do algebra, you always do the opposite, right? So if the 0.4 is added, the opposite of adding is subtraction. So I subtract the 0.4 from both sides. So that gets rid of that. So I have 3x equals, and $1 minus 40 cents is 60 cents. Right? Last step, what am I going to do with that 3? Am I going to subtract that 3? No, the 3 is not added to the x, is it? It's right up against the x. Right up against it. What does that mean, right up against it with no symbol in the middle? Times, so I have to divide it, don't I? I got to divide, because you're always doing the opposite. That'll be 0.20, 0.20. So B, C, and D are all 0.20. What's the probability the driver B will win? 0.20. Is it none of the above? Is that the answer on 20? Somebody have the answer? They're at the end of the inning. We'll assume it's true. It's just a little concerning.
The answer is B. It's B.
Oh, thanks, Johnny. Right. I was trying to demonstrate how easy it is to miss a small word. Yeah, I really did demonstrate, didn't I? Yeah, watch out. It's even for me it's easy. I do this for a living. Yeah, watch out. That little knot wrecks the whole thing, doesn't it? Will not. Let me circle it. Will not. So if the chance though, so B, where I'm getting totally lost in my 0.2. 0.2 is the chance. That's what X came out to be, right? So that's B, C, and D. They're 0.2, 0.2, 0.2. They each have a 20% chance of winning. So if they have a 20% chance of winning, what's the chance they won't win? They will not win. 80%. See the trick there? Watch out for the not. That 3 little word changes everything. So is that a little messy? Let me go back over this again. So they all have to add up to be 1.0. A is 0.4. These 3 are the same, so x, x, x. So 0.4 plus 3x is 1. Subtract 0.4, get 0.6, divide by 3, get 0.2. So x, which is what b is, c is, and d is, they're all x, they're all 0.2. So the chance that b is going to win the race is 0.2, but the chance he will not win is 0.8, right? It's 1 minus 0.2, which is 0.8. Whenever they say not, you subtract from 1, or 100%. Right? That good? A lot of questions. 45, man. I see why you asked, what if we don't get through?
Yeah.
I'm flying and I'm having trouble. All right, what are the odds? So what did we have? We had A was 0.4, B, C, and D were each 0.2, right? Okay, now what's that? What are the odds that D will win? Okay, so the probability for D is 0.2. That's just right here. How do you make that odds? How do you turn a probability for D, which is clearly 0.2, into an odds? Remember, you got to make this a fraction. 0.2 is 2/10. Do you remember that? Do you remember how to convert a decimal to a fraction? It's 2/10. Reduce that. Divide by 2. Top and bottom, 1/5. The probability of D is 1/5. Hey, what if it was 0.02? What would that be as a fraction? 0.02. 2/100. You guys with me? I just want to make sure you're okay with converting from decimal to fraction. If they give you 0.02, that's 2/100, isn't it? Because look at it, it's 2 places to the right, 2 zeros on the bottom. If there's only 1 place to the right of the decimal, there's only 1 0 on the bottom. Tenths, right? That's the 10th place. This is the 100th place. That'll also work, right? All right, so I want to make sure. And then you reduce the fraction. So I reduced it. So the probability is 1/5, but they're asking me odds. They don't want probability. They want odds. So how do I convert from probability? You got to make it a fraction first. I turn this decimal into a fraction, which I did. Now, remember, probability is 4 over total. The bottom of probability is always total, isn't it? Odds start out the same, 4, but they end with against. Remember the difference between odds and probability? It's a subtle difference. They're almost the same. Very small difference. Probability is 4 in total. Odds is 4 and against. So they both start with 4. So they're going to start the same. This is going to be 1. And then what's the against going to be?
4.
Yeah, 4. Because if there's 5 people total, remember it's like a debate. If there's 5 people total in the room and 1 is for the issue, 4 must be against. Remember how to think of that? There's 1 person for the issue, 5 people total in the room, so 4 must be against. It's the other side. It's like a debate or something, right? So 1 to 4. 1 to 4. There it is the odds. So that's how we convert from probability to odds. Probability, just having your 3x5 card, probability is 4 over total. Odds is 4 and against. That's the only difference. Very similar. They start the same. Probability ends with total, always. Odds ends with against. Odds is like a debate, 4 and against. Okay. Finally, number 22. Chances of rain are 20%. Then the odds of rain. Okay. So the probability of rain is 20%. Chances of rain, 20%. Then the odds of rain. Okay, so again, we're going from probability to odds. What do you got to do? Make this 20% into 0.2 decimal, 2/10, 1/5. So that's 4 over total. So the odds are going to be 1 to 4 because it's 4. And again, same thing as the last one. They don't have 1 to 4. But they have 2 to 8, and that's the same answer. Would that have tricked you? The answer is 2 to 8. That's the same thing. Just like 1/4 is the same as 2/8. Does that make sense what happened there? So I took the probability 20%, made it a decimal, 0.2, made it a fraction, 2/10, reduced it, 1/5, and then odds, if 1 is 4 and 5 are total, then it's 1 to 4, but then that's the same as 2/8. So you just multiply them both by 2, right? It's like a fraction. It's just a sideways fraction. So 1/4 is the same as 2/8. Okay, onward. Okay, so probability of snow on Tuesday, then the odds. So here we go. So probability 0.125. You got to change that to a fraction. It's going to be 125 over 3 zeros this time, right? Because that's 3 decimal places. So 125 over 1,000. If you reduce that thing, divide top and bottom by, I guess, try 125. Does it work? Is it 1/8? Yeah, it is. It's 1/8. That just becomes 1/8. So that's 4 over total. And you want to do odds. What is odds? 4 and against. So if there's 1 and 7, right? If there's 8 people total, 1, 7. 1 to 7, that's the odds.
Do you always have to go through all of the fractions and stuff, or can you just keep it as decimals?
Well, how'd you do it with decimals?
Well, you do like 1.0 minus 0.125, which is 0.875. So it's 0.125 to 0.875, which is 1 to 7. Because they add up to 8.
Yeah, that'll work. That's another way. That'll work fine. All right, let's keep going. Suppose the odds of winning grand prize are 1 to 7 was probably, now they're starting with odds 1 to 7, and they want me to go back to probability. So remember remember the definition. That's 4 and against. Odds 1 to 7 is 4 and against, and probability is what? 4 over total. So it's 1. They start out the same. No difference there. So if there's 1 for the issue, 7 against the issue, how many total? 8, 1/8. 1/8. A. Hey, another 2 more A's. There's been a lot of A's. Let's keep on moving. Number 25. Answer the question based on the following situation. 250 students in a math class take the final. Scores have a normal distribution. Center 75. Standard deviation 10. Plus 95% score between. Boom and a boom. All right, let's. Okay. 42. Dishonest coin. Heads, 2 fists. So it's not a fair coin. Heads is 2 fists. Tossed 1350 times. Blah, 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 blah. So all these ones, we had a formula which says mu is n times p. And they're flipping a coin, die, whatever, and they're doing and they're asking you for mu, the mean, the middle. It's n times p. Remember that we said that a couple days ago. So n is the number of times, and p is the probability. So what number of times is 1350? Probability for heads is 2 fifths. So take your calculator, multiply by 2, divide by 5. I'm getting 540. Y'all getting that? That's the mu, 540. There it is. Next one asks standard deviation, sigma. That's the square root of n times p times 1 minus p. You want to definitely have those two formulas on your 3x5 card. And so that is n, which is 1350, times p, which is 2 fifths, times 1 minus p, or minus 2 fifths. Hit the buttons on your calculator. Make sure you can. That's not an easy calculation. I'm getting the square root of 324, which comes out 18. Able to get that? Have any trouble with the calculator, grab me after class. I'd be glad to help. Just take a minute. Make sure you can get that one, 540. Make sure you can do that inside. It's a little tricky. I got 324, then I square rooted it 18. Now that I have those two, they're going to ask me a whole barrel of questions that just have to do with the bell curve. The, what's it called? The normal distribution. I'm just going to draw the bell curve now. Am I good to there? I'm going to flash off the screen if you're okay in that. If you have any trouble with the calculator, come grab me right after. Just take a second. All right. Okay, so what do I got? I've got the mu was, what was it? It was 540, right? The mu, well, let's go back here. Yeah, 540 and 18. 540 and 18. Mu was 540. Sigma was 18. So what I'm going to do is draw the normal curve. One big line in the middle. 3 jumps to the right. 3 jumps to the left. You know the drill, right? Percentages always remain the same. 34%. This is the most important thing you're going to have on your 3x5 card, is the percentages on the normal curve. You wouldn't want to skip that. That's going to be like several questions. Okay, and here's the middle. And the middle? So the percentages are always the same from problem to problem, aren't they? The percentages are always the same. What changes from problem to problem is the numbers on the bottom. So you put the middle down, 540, and then you what? Add 18. 558. Add 18. 78, 576. Add 18. 594. And then the other way, subtract 18. 522. Subtract 18. 504. Subtract 18. 46, I think. Okay. There's our bell curve. Now they're going to ask me a bunch of questions based on that bell curve. Okay, so here we go. Here come their questions. Everybody see how I made that bell curve? Right? Once I have the middle, and I have the sigma, which is the jump amount, I put the middle down and just add 18, add 18, add 18 to the right, and subtract 18, subtract 18, subtract 18 to the left. And the percentages are always the same for every bell curve. So what's the chance it's 540 or less? Half. 540 is the middle. 540 or less, that's half the curve, 50%. Easy question. What are the chances it's 522 or less? Well, here's 522. Or less. Which way is less? Left or right? Less is left. So it's this way. So then we have this, this, and this. So you add up 0.15%, 2.35, 13.5, 15 point, is that 15.75? Did I do that right? Maybe I did that right. 25. Did I do it wrong? Yeah, it's 16. Oh, yeah. I can't add today. At least not by hand. 16%. Thank you. 16%. Good? On that? Okay, let's keep moving. Alrighty. So here we go. Blah, 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 bell curve, middle, standard deviation. You know the drill. In fact, let me just go to a fresh screen here and draw a big old bell curve. Big bell curve. Middle, 3 lines to the right, 3 lines to the left. The percentages always remain the same. 34, 34, 13.5, 13.5, 2.35, 2.35, 0.15, 0.15. Okay. The middle, it's saying, is 75, and the jump is 10, right? The middle is 75, and the jump from line to line is 10. So the middle is 75, and then add 10. See what I'm doing? Add 10, add 10, add 10. So the middle is 75, add 10, add 10, add 10. And then the other way, subtract 10. So 65, 55, 45. We good? Let's go back to the questions now. 95% of the class. 95%. Remember, where do you find 95%? Johnny, you know it. I can see it.
Percentiles?
Well, it's 95%. I just mean like which of these percentages add up to be 95? Let me... Okay. No, I didn't want that. No, I'm still doing the wrong thing. Okay, there's what I want. I want that. Okay, so there's what I want. Yeah, anyway, so let's add up the percentages. I'm going to scribble on this. I just want to make another copy. So, okay, if you add up the two middle ones, these two middle ones, you get 68%, right? From there to there, from this line to that line. Let me give a little more room here. If you go further, if you go from this line to this line. Add up all 4 of these. Guess what you're going to get?
95%.
There's your 95%. That's the 95% they're speaking of. It's the 4 center ones add up to be 95. So that goes from where? From 55 to 95. Everybody see that? From 55 to 95, whatevers. I don't know what these things are. What are these things? Oh, how many math questions they got right or whatever. Anyway, 55 to 95. There we go. D. Next question, 26. Approximately what percentage of students score between 65 and 75 points? So this is some kind of math exam and how they did on the exam. How many students, or what percentage of the students got between 65 and 75? So let's go look at that. 65 and 75. Here's 65, here's 75. 34%. There it is. Next question. Peter scored at the 16th percentile. Ah, that's a great question. Do you remember what does 16 percentile mean? 16% below. Remember, percentile means percentile, we talked about on Monday, no, Tuesday, is percent below. Really important to know, for sure a question on the final exam next week on percentile. In real life, they use it all the time. Percentile means percent below, percent to the left. Percent below, percent to the left. So they're saying, hey, on that curve, bell curve, U-shape, bell curve thing, find what spot has 16% to the left. Okay. Well, I would start on the left and start adding this and this and this, and you'll find it's right here. This spot right here, these all below make 16%. If you add up this and this and this, you'll find they total 16. 0.15 plus 2.35 plus 13.5 equals 16%. So what spot? 65. Peter must be right there. Because where he's at, he must have gotten a 65 on that thing because 16% are below him. He's at the 16th percentile, meaning 16% are below. Remember, that's what percentile means? So Peter must have got a 65. Peter must have got a 65 if he's at the 16th percentile. Carol got 85. What's her percentile? What's her percent below? Percent to the left. If she got 85 on the exam. So Carol got right here. Carol got right on this line, 85. Let me go to a fresh screen here. Yeah. Oh, wait. So if I have a fresh screen. Yeah, there we go. So if Carol got 85 right here, for Carol, what percentage is below her, to the left of her? Well, all these, right? You with me? This is Carol. Carol got right here at an 85. What percentage is below her? What's her percentile? Percentile means percentage below, right? So what percent is below her? 50 plus 34, right. Because all of this right here is 50% because half the curve. Plus 34%, Carol must have 80% below her. 84% below her. She's at the 84th percentile, isn't she? She's at the 84th percentile. Good? Making sense? Keep moving.